class, today's lesson is on Thomson experiment. We have already studied the concept and now let's see how to apply the concept in Thomson's experiment. This is class by Raj teaching for physics semester 2 form 6 and STPL. Hi class, today's learning outcome will be to explain the principle of the determination of the specific charge ratio for electrons in Thomson experiment. Sir Joseph John Thomson was a British physicist, credited with the discovery of the electron, the first subatomic particle to be discovered. Sir Joseph John Thomson was a British physicist and a Nobel Prize winner. He was well known for the discovery of the electron. In 1897, he showed that cathode rays were composed of very small negatively charged particles. This particle later were named electrons. The apparatus of his experiment is called the cathode ray tube. Apparatus here in Thomson experiment. Okay, everybody is familiar here. Alright, so what happens in this position here? Okay, now you can see there's a cathode. Okay, this is a cathode here, so definitely an electron is emitted. Okay, an electron is emitted, number one. Okay, now from the cathode, the electron is emitted from the cathode. Number two, you'll realize that the electron goes through here. The electron goes through here, which is in this position here. So this is an anode. Okay, so definitely the electron are being focused and accelerated by the anode. So the electron are accelerated. Okay, the electrons are accelerated by the potential difference between the cathode and anode. Okay, so they are accelerated. So this is a positive here, we can see this is a negative here. So here there is an important concept. The concept is E volt is equals to half mv square. Okay, if I want to use QV also can. QV equals to half mv square. But to be noted, the Q is a negative charge. Okay, assuming that the Q is a negative charge. Or you can be very specified, you can just put in as E. Alright, to specify it from the beginning. Okay, then next part, the beam of electron will enter into this field. Now what happens in this field? Okay, what happens in this field? Now in this field, you can see that the magnetic field is into the page, and here is a positive and negative, so the electric field is in this direction. Okay, so the magnetic field is into the page, the electric field is in this direction. That means it is perpendicular. Okay, so the E and the B are perpendicular. Number one, the E and the B are perpendicular. Okay, alright. So when the electron beam enters into this region, the electron beam will be excited by two fields. One is the electric field and one is the magnetic field. Okay, one is the electric field, one is the magnetic field. That means the electron will be excited by a force, by two force. One is Fe and one is Fm, magnetic force and electric force. Okay, alright, so when it enters into this region, then after that the electron will pass and hit on the fluorescent screen. Okay, let's look at three situations that can possibly happen. Okay, alright, if number one, no E That means E is equals to 0, B is also equals to 0. Okay, so when the electron are emitted, the electron accelerate. Okay, the electron accelerate. It enters into the region, the E is 0 and the B is 0. What will happen? The electron will not be deflected because there is no electric field, no magnetic field. So the electron will straight go and hit on the fluorescent screen, and a light spot can be seen straight. Like this big light spot can be seen. Okay, a light spot being noted. Okay, was noted. Okay, situation number 2. Alright, if we turn B, E and B on, we turn E and B on, what will happen? Then the electron beam will stay undeflected, assuming that the Fe is equals to Fm. Fm is equals to Fe. That means Fm is B. Either I want to put Q or small e, yeah. So I'm going to just put Q. V equals to QE. Okay, V is equals to E over B. Okay, alright. Okay, if you don't want to put Q, you can also put B, E, V equals to E, E. So V equals to E over B. Okay, again I explain the reason why I put Q, because I know it's a charge, it's a negative charge. Okay, alright, but to be specified, you can just put a small e. Alright, so situation number 2. Situation number 3, if B is turned off at this position here, B is turned off. That means the electron, okay, I'm going to write here, yeah. The electron will be affected or will be exerted by electric force. Correct? It will be exerted by electric force because B is turned off. So when it enters into the region, only an electric force will act on the electron. So in this case, if it is here, it's a negative, right, electron. So the direction will be here, the direction of Fe. So you realize here that when it comes here, this is the direction. So the path of the electron, okay, the path of the electron will be straight hit on the fluorescent screen. Okay, so it will be deflected, it will straight hit on the fluorescent screen. Okay, alright, so it will look something like that. Okay, so what can we say? The electric field will deflect the electron beam. Okay, the electric force or the electric field will deflect the electron beam. Okay, what is the electron beam? Electron beam is fast moving electron, which is a cathode ray. Okay, alright, so it will hit here. So we look at part 2, we're going to study about this blue line. This path is a projectile path. Okay, alright, so this is about Thomson experiment, where we study about his experiment here. Okay, at part 2, where we are going to focus on the concept which is going to involve the concept of electric force and also the concept of projectile motion. Okay, alright, now the electron enters the electric field with a velocity v. Okay, here we can see what? Number 1, the electron enters, okay, enters the electric field with a velocity v. Okay, the electron enters into the electric field with a velocity v. This electron will be exerted by a force. Okay, this electron will be exerted by a force. Okay, what force? Electric force. Fe. Okay, this electron will be excited by a force which is an electric force, which is Fe. Okay, and we know Fe is equals to, either I want to put QE also can, or I want to put E also can. Q means I'm already consider this as a negative charge, or you want to be very precise, you can also put small e. Okay, now so the only force that is exerted upon the electron is an electric force. So the resultant force is equals to the electric force, which is QE, and the resultant force is MA equals to QE, then A is equals to QE over M, which is, that shows that the electron will be accelerated in the electric field, because got A, right? So the electron will be accelerated. Okay, the electron will be accelerated. Alright, so that is number 2. Okay, number 3, we are talking first number 1 and number 2. Number 1, okay, number 2, we are talking about what happens at the beginning here. Number 3, we are talking about that the electrons will be accelerated here, correct? Okay, now let's talk about here. What happens here when it follows a parabolic path? Okay, now this is already a parabolic concept. Alright, so here when we talk about parabolic concept, okay, if we start from here, okay, I'm just going to draw here. Okay, so this is the path of the motion. Alright, now here is the horizontal component. This is the vertical component. This is the horizontal component. Okay, horizontal component, the velocity always remain constant. Velocity always remain constant. I think everybody knows that, yeah, the concept in projectile. The velocity remain constant. The one will be changing is the vertical component. Why? Why the one in the vertical component will be changing? Because it is in the vertical component that is affected by the force, Fe. Okay, so the vertical component is the one which will be changing. What is changing is the velocity will be changing. Okay, that is one. Alright, so time taken. Okay, this is number 3, yeah, this is number 3. Number 4, let's talk about number 4. Number 4, time taken to traverse the electric field. Okay, from here to here, to traverse, because the electric field is from here to here, correct? So time taken from here to here to traverse, that means to pass through the electric field. Time taken, we know the formula as V equals to S over T, correct? So here the V is V, the S is the L over time taken from here to here to traverse the electric field. So T is equals to L over V. Okay, number 4. Alright, okay, now let's find out about number 5. Okay, let's look at number 5. Number 5, we are going to find the vertical displacement. That means S. S is a vertical displacement. Okay, now let's look at S equals to UT plus half AT squared. So S is a vertical displacement. So if I draw here, this will be S. Correct? Alright. So at the beginning here, the UY is 0. Okay, it's affected by Fe. That means it's also affected by A. Okay, acceleration. So therefore, S equals to UT plus half AT squared. U is the initial velocity, which is 0, t, plus half. What is A? A I take from here, okay, which I'm also going to put there QE over M. You can also put it as EE over M, small e, you can replace it with small e. Okay, so what is the T? The T is L over V, so I get L square V square. Okay, V is a velocity here. Okay, so the S, how do we find the S? Half QE L square M V square. Alright, okay, so is the velocity of the velocity of the electron. Okay, now next, number 6. Okay, number 6, point number 6. So let me take another color pen. Point number 6. Alright, let me see what color can I use. Point number 6. Okay, let's focus on this part here. Okay, now the electron will travel in a straight line. Okay, you see the electric field is from here to here only, correct? Okay, so after that you realize that the electron will travel in a straight line and hit the screen at P. Okay, so if I draw a triangle, okay, so this is O, this is P. Alright, I'm going to start with C. See this point here. Okay, so this is C, P, O. Okay, I'm going to assume this is a triangle here. Alright, okay, and then we have another triangle here. Alright, I'm just going to draw here the first triangle. Okay, and then we have another triangle which is same color. Okay, can you see that? Alright, so here there's another triangle here which is S. Okay, and from here, from this point to this point, this point to this point, okay, is L over 2. Okay, based on this, from C to P is X. Okay, and then this one, S is from this point to this point. Okay, this point to this point, and this one to this one is Y. Okay, alright, so therefore I can say by equivalent triangle I can say S over Y is equals to L over 2 over X. Okay, S over Y is L over 2 over X. Your maths. Okay, alright, so S is equals to L over 2 YX. Okay, now what is S? S is, okay, before we go to what is S, let's look at this formula here. Okay, so S equals to, we bring back this formula here, 1 over 2 QE M L square V square. V is a velocity, yeah. Okay, and then S we substitute here, equals to half QE over M L square V square. Why I put different color is this one is from here, this one is from here. Okay or not? Then I will get my E over m, which is Q over m, okay, and then equals to L y 2 v square divided by 2x E L square. Okay, I know I didn't arrange it properly, right? So now I'm going to arrange it. Okay, before I arrange it, because Thomson experiment is to determine the value of E, right? So here my Q is actually represent a negative charge. So I can also put Q as small e to be very specify. So E over m is equals to 2 L y. I arrange this, yeah, because the 2 is here, so I rearrange this. 2ly v square divided by 2x E L square. Okay, alright, and then this v, this velocity, we go back to the concept of v is equals to E over b. Okay, we go back to the concept of the first part, which we found here. V is equals to E over b. Okay, so we substitute here, we get E over m equals to 2 and 2 we can divide. Okay, L and L, so here we have y E square over x E b L. Okay, then we can cancel the E, we will get y E x b, okay, wait, I forgot my square here. Okay, b square. Okay, and then we have one L here, so L. So I rearrange this formula, make it more better. E over m is equals to E y, okay, b square L x. Okay, now I substitute the v as E over b, since it's square, so E square b square. Okay, so I substitute this. Okay, then I solve it, I cancel E, I cancel the E, so I get y E over x b square L. So my formula will be, now the formula for this specific charge ratio, okay, specific, this is called specific charge ratio, that is charge over mass, is equals to E times with y. E is the electric field times with y divided by magnetic field times square times with L. L is this distance inside the electric field, and x is from here to here. Okay, so you get your answer. Okay, now is it necessary to memorize this? It's not necessary. This Thomson experiment is just to let you know how to actually apply the concept in solving his experiment. So it's all about, the main thing about this concept is that when an electron enters into the electric field, the electron will be excited by electric force. The second concept is that it will go through a path of projectile. So that means all this is a projectile concept, and this one is more on maths. Okay, this one is all projectile concept. Okay, so from there we can get a formula. Okay, so that is all class, the lesson for today. Thank you.